This example is from section 14.2 in MGF 1107 when we're asked to find an Euler path in a graph. In this example, we do have a graph on the right hand side, and we are asked to determine a Euler path that begins with vertex A. Now, in this problem, they've already started an Euler path by giving you A, D, E, A. And they have numbered the edges as they have been used. Now, to complete the Euler path, we have to make sure that we traverse or use all of the edges that are in the graph. Remember, Euler paths deal with edges. We want to use every edge exactly one time. So from A, we could proceed to D again, D, comma. From D, we could go to C. That's our fifth edge, C. From C, we could go to E. From E, we could go to B. From B, we could go to A. You notice it's perfectly fine to use the same vertex more than once, but we can use each edge exactly one time. So that was 6. This one was 7. This edge here, BA, edge BA was 8. Then once we're at A, we can come back to B for number 9. And then from B to C for number 10. So the last vertex was C. So we have an Euler path, AD, EA, DC, EB, A, BC. And we've used every single edge in the graph exactly one time. Thus, that's an Euler path. You notice this Euler path is not an Euler circuit because we began at vertex A and we ended at vertex C. So this is not an Euler circuit. It's just an Euler path. One thing that you could remember from earlier on in section 4.2, there was a theorem called Euler's theorem. And Euler's theorem dealt with the degree of the vertices. And it said if you had exactly two odd vertices, such as C is an odd vertex because it has degree 3, and A is an odd vertex because it has degree 5, the other vertices are all degree 4, which are even. But what Euler's theorem said a graph with exactly two odd vertices has at least one Euler path, which we came up with, but no Euler circuit. So it says each Euler path must begin at one of the two odd vertices and it will end at the other odd vertex. Thus, since the directions told us to start at A, vertex A, which is odd, we knew if it had an Euler path, it was going to end at vertex C, which is the other odd vertex. If we started our Euler path at vertex C, we would know that there is at least one Euler path, and if it started at C, it would have to end at vertex A.